Hey everyone, it's Mr. Canfield, BC Calculus. We're going to do some derivative homework as a review. So I'm just going to go through the problems. If this is helpful for you, please let me know. If it's not helpful for you, please let me know. If you need something different, I'd love to do that for you. Okay, let's go. All right, the function f is differentiable and has values as shown in the table above. Of the following, on which interval is the average rate of change of f greatest? So average rate of change, remember our formula for that. So average rate of change is f of b minus f of a over b minus a. Literally slope. I don't know why I used capitals. We usually use lower cases. B, A, B, A. All right, good start, Canfield. So this is really saying out of these four ranges, which one has the greatest slope? So let's see. In our first one, from 0 to 2, like you could do the formula for all these, like 2 minus 0, and then on the top, it's the f of b minus f of a, so -2 minus -8. That's -2 plus 8, which is 6. So 6 over 2 is 3. Okay, so this one's 3. Let's do our next one, from 2 to 6. That's 6 minus 2 on the bottom, which is 4. And the top is going to be f of 6, which is 0, minus f of 2, which is -2. So 2 over 4, 1/2. Okay, so b is already less than a. And I am just finding the slopes, and one of these slopes is going to be the greatest. So if you want to do it a little bit faster, 6 to 12 is 6, and then 0 to 2 is 2. So it goes up 2 over 6, which is 1/3, but you could do the formula as well. But it is just, just plug them in. Then 12 to 20. 12 to 20 goes up 8, because 20 minus 12 is 8. That goes on the bottom. 2 to 18, that's a difference of 16, so that's 2. So A was our answer there. Ooh, I do not have the answer key pulled up for this. That's fine. So, I will make an addendum if I need to correct anything. All right, here we have a piecewise function. It says, wait, the freaking College Board's trying to do a verify. I just logged in. All right, okay. Anyway, g is the function given above. What is the average rate of change on the closed interval from 1 to 5? Okay, so in order for this to work, it needs to be differentiable all the way through. So we need to double check that at x equals 3, we actually have a valid function. Like we want to make sure, like, do we have a function that's like something weird like that? Oh, I guess it's, well, x squared plus 1 is this kind of thing, and then 13 minus x is this kind of thing. So we want to make sure that their transition is smooth. We need to make sure their derivatives are equal to each other at x equals 3. I mean, and their y values for that matter. So like if we check the y values of x squared plus 1, we want to make sure that that's equal to 13 minus x when x is 3, because that's when they're supposed to trade places. So x squared, so 3 squared plus 1, it's 9, plus 1 is 10. 13 minus 3 is 10 as well. Okay, so the y values check out. Now we got to check their y primes when x is 3. So that's 2x, and that's -1 when x is equal to 3. So if we check there, we get 6. 2 times 3 is 6 equals -1. That is false. And that means it's not differentiable at x equals 3, meaning this is undefined. 3. For values of h very close to 0, which is another way of saying the limit as h goes to 0, which of the following functions best approximate this? So tangent x plus h minus tangent x over, hey, wait, that looks like the definition of the derivative. We're taking the derivative of tangent, and the derivative of tangent is secant squared, and so that's our answer. No real work to do there if you recognize the form. Okay. Number 4, what's the average rate of change of y is equal to cosine of 2x on the interval from 0 to pi over 2? So it's average rate of change. Remember, that's y2 minus y1 over x2 minus x1, or f of b minus f of a over b minus a. So literally just saying cosine of 2 times pi over 2 minus cosine of 2 times 0, okay, over b minus a. Okay, let's see. Cosine of pi minus cosine, so because the 2 times the pi over 2 cancels out, we're left with pi. 2 times 0 is 0. You either know these or you don't. And pi over 2 is on the bottom. So we already know our final answer, like we're gonna get something here and it's divided by pi over 2. To divide by a fraction like that, we're gonna have some number here divided by pi over 2. That's times 2 over pi. So whatever we end up with, there's gonna be a pi in our denominator. So it's either gonna be a or e, just from that. Now finding this part here. Let us be transported to the world of the unit circle. All right, so bam, bam, circle. It's a, whoa, hello. It's a circle. Okay, so a couple reminders from the unit circle. It goes cosine theta, comma sine theta. And the big deal there is unit means 1. The radius of this circle is 1. That means this is the point 1 comma 0. This is the point 0 comma 1. This is the point negative 1 comma 0. And this is the point 0 comma negative 1. So if I'm going to be using my unit circle here to figure this out, which that's how I do this, cosine of pi. Well, where is a pi? Well, if we know the whole thing, remember we always go, this is the direction the angles go. We go all the way around, and that's 2 pi. Well, to get to 1 pi, it's only half of that. So this is 1 pi over here. And so the x-coordinate at 1 pi is negative 1. So that turns into negative 1 minus, then cosine of 0. 0 is the start right over here. So cosine of that is 1. So negative 1 minus 1 is negative 2. So this is negative 2 divided by pi over 2, which is negative 2 times 2 over pi, which that's over 1 then. We multiply straight across. We get negative 4 over pi. All right. Cool, almost on the first page. Only a lot more to go. So, let's see how I can just kind of pause the video in the middle of me flipping. Does that work? Just kidding. All right, so got the luxury of this. Okay. Let f be a differentiable function. Oh, I don't know if I said this earlier. Differentiable just means we can take the derivative of it with selected values given in the table above. What's the average rate of change of f over the closed interval from 0 to 10? Literally, we do the average rate of change formula, which is f of b, f of 10, minus f of a, which is 0, so 5, over b minus a, 10 minus 0. And this number is negative 25 over 10, which is negative 2.5, or let's see, they're both divisible by 5s, so negative 5 over 2. So there we go, negative 5 over 2, there's my answer. Oh gosh, I just wrote on somebody's paper that I wasn't supposed to. I'll also have to make more copies. All right. If, number 6. If f is the function given by f of x is equal to 3x squared minus x cubed, then the average rate of change of f on the closed interval from 1 to 5 is, literally, f of 5 minus f of 1 over 5 minus 1. Is this calculator? No. If it was calculator, I would literally just type this into my calculator and have it do it for me. It is not, so I cannot. So let's see, I'm supposed to plug in 5 here. So that's 3 times 5 squared minus 5 cubed. 5 squared is 25, times 3 is 75. 5 cubed is 125. Was that negative 50? And then f of 1, so that's 3 times 1 squared minus 1 cubed. That's 3 minus 1, which is 2. So this is negative 50 minus 2. I got negative 52 over 5 minus 1, 4. So, and then what is that, 13? Because I know 4 times 12 is 48, and that's 4 more, so yeah. So negative 13 is what I got. And I am doing my darndest to get this answer key loaded while we're doing this. All right, this is a calculator question. To be fancy, I will say calculador question. Let's see, we encountered an error. Thanks, College Board. All right. The function f is given by f of x is equal to the integral from 1 to x of this dt. What is the average rate of change of f over the interval from 0 to 3? So literally this means f of 3 minus f of 0 over 3 minus 0. And this is something my calculator can do. So messy, let's see, what does f of 3 mean? It means you plug in 3 for x here. So that is from 1 to 3, the integral of t cubed plus 2 dt. How do I get that? I type it into my calculator. So I'll do, and you absolutely could do this. Ask me in class if you want me to show you how this is super easy to type in. And it's just kind of tracking things. And there's several ways that we can do this. And yeah, so we should go over all those when we're talking about this in class. And then you get one of these answers. I don't know which one. And that is all I'm going to say about that one. All right, next one. When x is equal to 2e, find this. So when x is 2e, find that, this is the definition of the derivative. And what's our original function? Right there, ln x. Well, so what's f prime of ln x? Just 1 over x. But it says x is 2e. So plug in a 2e where x is, 1 over 2e. That's it. Like, seriously. That's all you gotta do. I hope. It is slowly loading my answer key, so I'll be able to boy, I love the internet. I love that I'm not like, I could very easily right now just pause the video. Oh yeah, right. Hi, I'm back. I'm gonna fix number 2 real quick. So although it's got this discontinuity, this non-differentiable part. So hey, come back to number 2 real quick. Sorry. So it doesn't matter. You can still calculate average rate of change even if it misses some stuff in context. So you just would do f of 5 minus f of 1 over 5 minus 1. I was overthinking it. I could have just applied the formula. So when x is 5, that's this one here. So we would do 13 minus 5 and get 8. So 8 minus f of 1, that happens when x is less than, so 1 is less than 3, so 1 plus 1 is 2, so 8 minus 2, and then from 5 minus 1 we get 4, so 8 minus 1 we get 6 over 4, we get 3 over 2. Okay, my bad. All right, let's see what other mistakes I made. I'm just gonna go check the rest of my answers. I'm always learning. All right, that's good. Let's see, 5, we're good. Where the heck? Wait, I lost one. There's that. Oh, there it is. Okay. Okay. All right. If you were doing 7, the correct answer is E. If that doesn't match up, yell at me about it. And that's A. Okay, cool. So that was my mistake. Everything else is good. Here we go. Next question. limit as h goes to 0 of this mess looking thing. Can I look at this? Let's see, because it's supposed to be f of x plus h. So I would expect to see like e to the x plus h, but I don't see that. I see minus h. So could I do something to e to the negative 1 minus h to convert it into the form that we care about? And am I overthinking it, and is it really just going to be b? Or sorry, d. I think it's going to be d. Okay, no, I'm underthinking. All right, here we go. Here, let me do some more work. Okay, so this is a tricky one. I'm trying to figure out like how to fit this into, because it's supposed to be minus f of x here. So, but this minus h is throwing me. It's normally plus h. You know what? I bet that doesn't even matter. What do you bet it doesn't even matter? Because then we can just, like, if we're saying this is e to the x, right? The derivative of e to the x is e to the x, and then you plug in your x value. So e to the negative 1, that's 1 over e. So that's not, okay, that's not the right answer. So there is something weird going on because of this not being plus h. So let's fix this then. So I'm going to factor a negative 1 out of this and turn this into 1 plus h. Is that okay? So now I can think about this as it being e to the negative 1 times 1 plus h minus e to the negative 1 times 1. Our function is e to the negative x. So when we take the derivative of e to the negative x, what do we get? We get negative e to the negative x. And then when we plug in our, looks like we're plugging 1 in, so when we plug 1 in, then we get negative 1 over e. So, strange one there. Glad I put it on. All right, let's keep going. Limit as h goes to 0, number 10. So this is just, if y is equal to sine of x, then y prime is equal to cosine of x, right? So it's saying of pi over 3. So cosine of pi over 3 is, hello, old friend. Well, pi over 3 is before pi over 2. It's up here. And it's got, we know its coordinates are either 1/2 root 2 over 2 or root 3 over 2. Like, those are our only options for numbers here. So if I think about where this is located, this is the smallest, this is the middlest, this is the biggest. And we've got these, these 3 lines. This is the farthest to the left. So we're going to use the least number for cosine and the biggest number, because it's the highest out of the 3, for sine. Okay. Cosine pi over, cosine's x coordinate, so 1/2. It's just 1/2. Computer, show me 1/2. All right. Onward and upward. Let me save my unit circle. Probably need it again later. All right, number 11. Oh, this looks so bad. Oh, it's literally just, can we figure out how to write this as f of x plus h minus f of x? Limit as h goes to, limit as h goes to 0. So see this x goes to 0? These are both wrong, and we know it. So anywhere you see an x here, you should plug in an x plus h, which is this. And then here it just stays the same. So you'll notice here they made a common mistake of you just adding h on the end instead of plugging x plus h in for each x. So hopefully you can see that. Man, I'm so funny. Ooh, we are over halfway. Arcsine. If the derivative equals 2, which of the following could be the value of a? So this is saying the derivative of arcsine when we plug in some number a. Well, the derivative of arcsine is that, I believe. I am almost positive on that. Let me break out my notes. Just wrote this down earlier today as a double check. What did I do with my notes? Remember, kids, always bring your notes to your videos. Oh, they're on the floor behind me. I think it's bad for you. Yeah. All right. Cool. Don't know why I bothered to check. So, if this is equal to 2, what could be a value of A? Really? I feel like, all right, okay, I'm just gonna solve this. So I'll multiply both sides by the square root and get 1 is equal to 2 root 1 minus x squared. I want to get rid of that square root, so I'll square both sides. That leaves me with 1 is equal to 4 times 1 minus x squared. I don't know what's going to be nicer. I'll just distribute. Nah, if you divide, I'm going to add the x squared over here to get rid of the negative, and then I'll subtract the 1/4. So x squared is equal to 3/4. So we need x to be plus or minus the square root of 3/4, which that simplifies to square root of 3 over 2 plus or minus. And there is our answer there. All right. So this went from, we just did some calculus, and then this is all algebra. Algebra is the hardest part of calculus most of the time. All right, if f of x is equal to this, what's the limit as x goes to -1? So this is an alternate form of the derivative, and it is just asking, what's the derivative of this when x is equal to -1? So let me take the derivative first. The derivative, well, I see it's cubed on the outside, so we'll do 3 and then bring it down to 2, leave the inside alone, and then multiply by the derivative of the inside, which is 2x. And that's the whole derivative. So then we can plug in -1. So 3 times -1 squared is 1. And then 2 times -1 is -2, so that's -6 here. 1 plus 1 is 2, squared is 4, so 3 times 4 times -2. I'm getting 12, -24. All right. Cool. Onward and upward. Number 14. The table above gives the distance s of t in miles that a car has traveled at various times t in hours during a 6-hour trip. The graph of the function s is increasing and concave up. Increasing means that s prime is always positive. Concave up means that s double prime is always positive. Based on the information, which of the following could be the velocity of the car in miles per hour at time t equals 3? So if we're trying to find the velocity, that's the derivative of hey brain, what are we doing? That's the derivative of position. So it's like 92 is probably not the answer. What we could do is we could look at rates of change that are around 3, and I'm not sure which one they want. Do they want me to test from 2 to 4? Because I could test from 2 to 4 and do an average rate of change, 150 minus 55 over 4 minus 2. So let's see, what is that? That's almost 100, so is it 95? So 95 over 2 is 47.5. Okay, well, so that's kind of close to that. Let me see if, so that's, the average from 2 to 4 is 47.5. Let me try, me try doing a wider one. So 5 minus 1, 210 minus 25. So that's 195 over 4. Are you serious? Oh, well, 200 over 4 is 50, so this is just under 50. So I again am honing in on this 49. I mean, we could go up further. We could also like kind of check these in here, but we're looking at high 40s, not quite 50. I think that is my best answer here. If you have a different way that you did that, please tell me. My answer key doesn't have much beyond that, but that's what I'm going with here. All right. Let's see. Let f be the given function. What is the instantaneous rate of change at x equals 3? Literally, f prime, take the derivative. So what, 3x squared minus 12x plus 8. Plug in 3. So 3 times 9, so that's 27. That's 36. I'm gonna do 27 plus 8. 35 minus 36. Oh, -1. Okay, I got -1. Is that an answer choice? It is. Is it? My lights went out on me. It is -1. All right, so I got it right. Let me turn the lights back on. I'm back. Oh yeah, I could have paused it again. The function f is defined by f of x is equal to x over x minus 2. What points x comma y on the graph of f have the property that the line tangent to f at the slope xy has a slope point? All right, my brain stopped like digesting what I was saying about there. Line tangent to f. That's derivative. Slope of 1/2. When do we have a derivative of 1/2? Okay. So I can do some, what's the derivative? Oh, we're gonna do quotient rule. So quotient rule says take the derivative of the top, leave the bottom alone, minus take the derivative of the bottom, leave the top alone, over the bottom squared. So we wanna know, when does this, let's simplify this real quick. So that's x plus 2 minus, the ones don't do anything, right? So it's just a 2 over x plus 2 squared, and that's probably the best form to leave it in. We want to know, when does this equal 1/2? So are there any x values that make this true? And then so what y values does that then potentially give us? So let's see. And cross multiply, you get 4 is equal to x plus 2 squared. If we take the square root of this, we get x plus 2 is equal to plus or minus 2 by square rooting both sides. But nothing. I'm going to pretend I don't know anything yet. All right, so plus or minus 2, so we'll subtract the 2 from both sides. So -2 plus or minus 2 is equal to our x. So we can either have an x value of 0 or -4. So when I go and I plug those back into my original, I get 0 over 0 plus 2, which is 0. So 0, 0, or 4, which, or sorry, the -4, which is what? -4 over -4 plus 2, which is -4 over -2, which is 2. So -4 comma 2. So I am getting this. So there's a potential problem in here. We take that square root there and bring in these multiple answers. There's a possibility that we have a domain issue in the end. If we had gotten x was -2, then we would have a discontinuity here, which is illegal. So we'd be like, no. So if we had gotten x was -2, then failure. I'm glad I didn't stop. I was like, oh, maybe I should stop here and like cut one of them out. No, don't stop there. Get the answers and then see where we have problems. All right. Or like, you know, down to here. Okie dokie. 17. The function f is not differentiable at x equals 5. Which of the following statements must be true? All right, so to be differentiable, it has to be continuous, and the difference quotient must work, the definition of the derivative. So must be true. This is definitely a possibility, but you can have a continuous function that is not differentiable, you know, any of those kinds of sharp points or cusps. Or like, you know, if you have a parabola meeting with a line, that's a discontinuity or a differentiability issue, but it's not a continuity issue. This is another thing where it's a possibility but not required. This one, this is saying the derivative as x approaches 5 does not exist. That's the big one there. So I do always double check. You know, I screwed up on number 2. Possible I screw up again. Sorry, probable, not possible. All right. All right, number 18. The derivative of the function f is given by f prime is equal to, for how many values of x in the interval from 0 to 2 is the line tangent to the graph y equals f of x at the point x parallel to the line y equals 4. So all these words, it's asking if it's parallel to this. Parallel means same slope. What's the slope of this? 4. This is asking, when does f prime of x equal 4? From 0 to 2. And this is a calculator question, so we'll check out my amazing multimedia capabilities. All right, just gonna film my screen here. We're gonna go to Desmos. Wonderful Desmos. I should have already loaded it up, but I'm loading it up now. All right, so y equals, and we could definitely do this nicer looking, but whatever. Cosine 3x squared minus 2, close it. All right, and we are looking on the interval from 0 to 2. So I'm gonna do like -0.2 to 2.1 just so I can get a better look. So here's what it looks like from 0 to 2, and then we want this to equal 4. So I get 1, 2, 3 times that this, so these are derivative values that I'm looking at, and I want to know every time they equal 4. I don't have to do any work, I just need to look at my graph, unless I said 3, right? 1, 2, 3. Yep, that's it. 3. Done.
Correct. If the line tangent to the graph.
All right, next. Almost done, I think. Number 18. Let f be a differentiable function. The figure above, this is going to be hard for you guys to read. I'm sorry about the way the computer decided to spit this out for us. Oof. All right. Oh wait, that might not be so bad. Okay. So this is number 19. So this is the graph of the tangent line at x equals 0. Hey, so what that means is at x equals 0, this So like we have some kind of curve. Who knows what the curve is, except here we're guaranteed it's tangent to whatever the heck our curve is right there, which means this is the slope. Wait, what's the slope of this tangent line? Let's see, I see here, so it looks like 1, 2 over 1, so down 2 over 1. That gives me a slope of -2. That means that f prime of 0 is -2. Okay. Of the following, which must be true? F prime of 0 is equal to negative f of z. Why? I don't know why that would be true. F prime of 0 is less than, how is that? Wait, hold on, this is a tangent line. That means it glances across our function, which means that whatever the y value of our function is, the y value of this line here is also the same. That means that they have the same y value when x is equal to 0. That means f prime of 0 is equal to f of 0. Kind of a weird way to talk about it. But yeah, that's what a tangent line is. It touches the function at that point. So it has the same y value. It also has the same steepness or the same slope. All right, 20. What is the slope of the line tangent to the graph of at x equals 1? Literally, taking the derivative. It's a quotient rule problem. So, derivative at the top is e to the negative x. Derivative of the inside of that's -1. Leave the bottom alone. Minus, because it's division. Derivative of the bottom, e to the negative x. And then bottom squared. So, at x equals 1. Okay. Now I just have to be careful with my algebra. So negative e to the -1 times 1 plus 1 is 2, minus e to the -1 over 1 plus 1 is 2, so 4. That's none of those. Okay, well, let's see if we can't clean this up a little bit. So it's a difference over 4. So I could write that -2 e to the -1 over 4 minus e to the -1 over 4. And hey, like e to the -1 means it flips. 2 over 4 is a half. So -1 over 2, and the e's down here now, minus 1 over e. Oh, sorry, 4e, not e to the 4. So I just need to get these to have the same denominator then. We got 2e, we got 4e. If I multiply this by, oh, I should have just left it. I should have just left that. -2 over 4e minus 1 over 4e gives us -3 over 4e. And please be right. All right, cool. Thank you, computer, for validating me. All right. What is the slope of the line tangent to the graph at where x equals 4? So just another derivative. So y prime is equal to 1 over 2x times the derivative of our inside, which is 2. Hey, 2 over 2 is 1, so it's just 1 over x. That's silly. Where x is 4, so a fourth. Done. 22. The function g is defined by g of x is equal to x squared plus bx, where b is a constant. If the line tangent to the graph of g at x equals -1 is parallel to the line that contains the points 0, -2, and 3, 4, what is the value of b? Line tangent to the graph deals with derivative again, is parallel to the point parallel to the line that has these points. Well, okay, we just got to find the slope of those points then. So 4 minus -2 over 3 minus 0. So 4 minus -2 is 4 plus 2 is 6 over 3. Okay, 2. Literally just asking if the line, so if the derivative of g at -1 is 2. Okay. Well, g prime is 2x plus b, because b is a number, and we need that to equal 2. And we know x is -1, so 2 times -1 plus b is equal to 2. So that's -2, so we'll just add 2 to both sides, so b is 4. That's it. And the last question. Let f be the function defined by f of x is equal to ln of x squared plus 1, and let g be the function defined by g of x is equal to x to the fifth. The line tangent to the graph of f at x equals 2 is parallel to the line tangent to the graph of g at x equals a, where a is a positive constant. What's the value of a? So f at x equals 2. Okay, so that is, the derivative of that is 1 over x squared plus 1 times the derivative of the inside, which is 2x. So when x is equal to 2. So then we're going to plug in 2. So is that 4 over 5? Oh, okay. The line tangent to the graph of f at x equals 2 is parallel, means same slope, to the line tangent to the graph of g at x equals a. Find a. Well, graph of g prime then is going to be 5x to the 4th plus 3x squared. We want to know, when does 4 over 5 equal 5x to the 4th plus 3x squared? Easiest way to do that, go back to our bud. Hello, buddy. Desmos, buddy. Oops. All right. So, this time I'm going to have it be y is equal to 4 over 5 is what I'm looking for it matching. And I want to know, when does 5x to the 4th plus 3x squared equal that? I am getting 0.447, which is, looks like it's C on our paper. Also, you just, with Desmos, you just click and it finds the intersection point. So let's see if I'm right. Hey, all right. So, hope that was helpful. Again, let me know what I can do to make this more helpful. And as always, bye.